Hello friends, this is a quick video to help you transform a basic trig function. So I want to start by going back to the things we've learned about the trig function. In the general form, we have four variables here that affect what happens. We've got the d, which is a constant. This will move the whole graph up and down. We have an a, which is a vertical stretch. We have a b, which is a horizontal stretch, and we have a c, which shifts the graph left and right. So when I look at a basic curve, I know the midline right away is going to be at this value of d. So whatever number is here, the constant that doesn't have a variable with it, that's where the midline is going to be at the line y equals whatever that d is. Then I'd look at the b, and that would tell me, if I took 2 pi over b, that's going to tell me what the period is, the distance that it takes this curve to go one complete cycle. How high the curve is going to be the absolute value of a. And if there's a horizontal shift, this value c is going to be the first value where the period begins. And then I would add whatever 2 pi over b comes out to be to find out the end of the period for the curve. So let's look at our problem here, and I want to start by doing the basic sine of theta. So when I have the basic sine of theta, the d value is 0 because there's nothing added or subtracted in front. The a value is 1. Assume there's a 1 there. The b value is also 1. We assume there's a 1 here. And the c value is 0 because there's nothing added or subtracted to the angle. So let's use those rules that we just got for a basic sine curve. The beginning of the period is at the c value, so there's a 0. Then I calculate the b. I do 2 pi over b, and since b is 1, the period is 2 pi. So this is where the period begins, this is where the period ends. And those critical values that we talked about, the min, the max, and the intercepts, are going to happen halfway between 0 and 2 pi, so that's 1 pi, and then halfway between 0 and pi, which is pi over 2, and 3 pi over 2. And I know that the intercept here is going to be always on the midline. So when I look at this, and the midline is d, which is 0, here's where all the intercepts for this sine curve have to be. So once I find 1, I've got all 3 of those. Now what's left to do is calculate the max, which we know from our unit curve, from the unit circle we've already looked at, that the max happens at pi over 2 and is 1, and the minimum happens at 3 pi over 2 and is negative 1. Now to calculate these values, I just want to be clear. You'd take that value of the sine, which is 1, and I would multiply it times b, and I would add d. So in this case, I'm going to do 1 times 1 plus 0, so I'm just going to get 1. And I would do the same thing for the minimum. I'm going to do negative 1 times 1 plus 0, and that's going to give me negative 1. All right, now let's look at this curve and see what's different when I add in some different values for a, b, and d. The first thing I want to notice is that the d value is 1. So that means my midline will be at 1. So let's just put that on right away. So I know now that these intercepts are all going to be at the value of 1. The next thing I'm going to do is look at the amplitude. And the amplitude is just negative 5. I'm going to take the absolute value of negative 5, which is 5. So I know that my max is going to be 5 units above the midline. So I'm just going to hold on to this thought, and I also know the minimum will be 5 units below the midline. But we also have this negative, which is going to make the graph reflect over the x-axis. So we're just going to use our little trick about multiplying the value of the sine times b and adding d. But let's figure out the period first. So I know to find the period, I'm going to do 2 pi over b, and that b in this case is 2/3. So 2 pi divided by 2/3 gives me 3 pi. And I know that this value here is c, and that there is no c. In this curve, c equals 0. So this value is going to start at 0. And the period is going to go all the way to 3 pi. And to find where these critical values are, I divide this distance from 0 to 3 pi in half, so 3 pi over 2. Then I divide the distance from 0 to 3 pi over 2 in half. I get 3 pi over 4. And I divide the distance from 3 pi over 2 to 3 pi. Another way to think of it is it's 3 pi over 4 plus 3 pi over 2. Either way, it's 9 pi over 4 right here. So now, once I know this period, once I know this, and once I know what c is, I have the beginning and the end of one period, and I can divide the distance between the two in half, and then the distance from the beginning to the middle in half, and the distance from the middle to the top of the period in half, and I have all the values for where these critical values are going to be. So the last stop is to take the minimum. So I know at the sine at pi over 2 on the regular sine curve, the sine is 1. I'm going to times that by b, which is -5, and I'm going to add d, which is 1. So that's going to give me a value of -4. And then I'm going to do the same thing over here. I would have a value of -1 times -5 is +5 plus 1 is 6. So that's everything I need to sketch this curve. I have an intercept at 0, 1. I have another intercept at 3 pi and another intercept at 3 pi over 2. Then I have a minimum at -4, halfway in between, right there. And then I have a maximum at 6 at 9 pi over 4, right there. And then I can just sketch this curve. Now these directions say to do at least 2 periods. So I could extend this curve to the right, but I already have this bit over here. It'll do the same thing on the previous. So I'll have an intercept at -3 pi and another intercept at -3 pi over 2. I'll have another minimum at -4, halfway in between here, and another maximum at 6, halfway in between here, and then I can just continue this curve.